Okay, 56 is going to have to be done like 55. Might want to go back and look at 55. Maybe that video will be a little more descriptive. But what we have here is we have a product of two matrices equal to a 2 by 2 matrix. So we know that this product, this matrix times this one, has to be 2 by 2 because by definition of equal matrices, they have to be the same dimensions. And if we check here, 2 by 2 can be done because the inner dimensions are equal. Therefore, the resulting product matrix is the size of the outer dimensions. So a 2 by 2 times a 2 by 2 is a 2 by 2. Just as 3 by 3 times a 3 by 3 would be a 3 by 3. So this can definitely be done. But we have to do it by hand. We can't do it in our calculator because of these x and y values. Now remember, in order to do this by hand, okay, we know our resulting matrix is going to be 2 by 2. So let's draw that matrix. Okay, we have an element in row 1, column 1, an element in row 1, column 2, an element in row 2, column 1, and an element in row 2, column 2. Okay, now in order to find these elements, remember, in multiplications, and I guess it's a little bit of multiplication in addition, the rows always comes from the first matrix, and the columns come from the second. So in order to get this element, row 1, column 1, we take the row of the first matrix, the first row of the first matrix, which is 2x and a positive 1, and we multiply that by the first column of the second matrix. So we multiplied that by 0, 2x. Once we've added these, or multiplied these, we add their products, and we get 2x. Oh, sorry, that would be 0. We get 0 plus 2x, which is just 2x. So this is the new element in row 1, column 1. Okay. Now, if we move to row 2, okay, remember rows comes from the second matrix. Okay, so we're going to have 2 and we're going to have 0, but it's still in column 1. So what you notice about these columns, this is 0 and this is still going to be 2x. Now we are going to find the sum of these two products, and what we get is 0 plus 0 is just 0. Now as we go, what we can do is just double check. When we get a constant term such as this, let's kind of look up here and say, okay, corresponding elements, row 2, column 1, okay, these are equal, so we know that we've done that correctly. But that is our new element in row 2, column 1. So now let's move over to row 1. So we're back to row 1, and if you notice here, this is going to stay the same, the 2x and the 1. Okay, but now we're in column 2. And columns comes from the second matrix. We have 3, and we have a negative y. Okay, so we have 3 and a negative y, and when we multiply these and then add these two terms, we get 6x minus y. So in row 1, column 2, our new element is going to be 6x minus y. Alright, and last but not least, we have row 2, column 2. Okay, now we're back to row 2, so we have a 2 and a 0. Still in column 2, we're going to have a 3 and a negative y. And then when we find these products, we'll add 6 plus 0 is going to give us 6. So in row 2, column 2, it's 6. Come up here and double check. And we know that we have at least found those bottom two elements correctly because they do match up with that equal matrix. Now again, take a look here. The 0, 2x, 2x, 3, 3, negative y columns are staying the same rows. 2x1, 2x1, 2, 0, 2, 0. So this is definitely a pattern. It's a repeating pattern that once you get it, does make this actually fairly easy. So our new product matrix is going to be 2x and 6x minus y, 0 and 6. And that is equal to negative 4, negative 9, 0, and 6. And what we see here is that 2x has to equal negative 4 by definition of equal matrices, and 6x minus y has to equal negative 9. Here 0 equals 0, 6 equals 6, so then we just divide x is equal to a negative 2. We're going to need that here, a little bit of substitution. We get negative 12 minus y equals a negative 9, therefore y, or negative y, equals a positive 3, and y equals negative 3. So for this particular problem, x equals -2 and y equals -3, and that's how you solve 56.